Welcome back to our next lesson involving dealing with quadratics, things with squares in them, all right? And these are two coordinate system geometry type problems that deal with finding the distance between 2 points and finding the exact midpoint between 2 points. In other words, you've got a line segment here, and it's got a point here which has an x and a y value, and it's got a point here that has an x and a y value. All right? We've called these x's x1, y1, x2, y2 for point number 1, point number 2. But it doesn't matter which you call point 1 or point 2. But please, these numbers have to be the same. This could be x sub 1, y sub 1, this would be x sub 2, y sub 2. It doesn't matter. You'll get the same answer no matter what. And the distance between this point and this point is what we're going to talk about how to find today. And we can also throw in a little extra bonus that's not really quadratic, but if we want to find the exact middle point between these 2 points, it can come in handy for various things later on, as you will see. So today we're focusing on 2 things, the distance and the midpoint formulas. And they're just basic formulas that you're going to understand, use, and plug in and use substitution and all the math toolbox stuff that you've been using, all right? So here we go. All right, so the distance formula for given points on a coordinate system. Distance is equal to the square root of x sub 1 minus x sub 2 squared plus y sub 1 minus y sub 2 squared. Now, being the bright student that you are, you should immediately recognize that this looks familiar. What's that? Yeah, it's the Pythagorean theorem. All right? We're simply using the Pythagorean theorem to find the distance, which is the hypotenuse, right? If you think about it, that's one leg and that's another leg, and the distance between them is the hypotenuse of a triangle we could make. All right? So, for example, here you've got x sub 1 and y sub 1. Here you've got x sub 2 and y sub 2. And again, it doesn't make any difference what. But this forms a right triangle. And the distance is the hypotenuse. All right? If only we knew the legs. Well, we do, because the legs are the change in y and the change in x. And we've done this with slope before. All right? We simply want to find the difference between one x coordinate and another x coordinate, x sub 1 minus x sub 2. And how far does it go to get from here to here going up is the difference between y sub 1 and y sub 2. It's a subtraction problem. All right? It's just the Pythagorean theorem all over again with a little subtraction thrown in. All right? So, if we have some actual thing here, we want to find the distance between, say, 3 minus 2 and 6, 4. Okay. I really recommend that you label these points. All right? If you're going to call the first one point 1, then this becomes x sub 1 and y sub 1. And then write down what x sub 2 is 6 and y sub 2 is 4. All right? Don't get them mixed up. It makes a difference. All right? So the distance formula says we take the difference in the x's and square it. And see, that's why it doesn't matter which one is 1 and which one is 2. If you come up with a negative value, it's going to get squared and become positive no matter what. The idea of squaring a difference always gives you a positive value, which is good because we don't want any radicals with a negative in it yet. All right? So x sub 1, 3, minus x sub 2, 6, y sub 1, minus 2, minus y sub 4. And remember, you're going to say this minus sign gets written immediately after you write the first number. Minus 2, minus. Then you look at the next point. All right? Because if the next point is negative, it's going to be minus minus, which will be a plus. All right? In this case, it's already a plus, so it's just minus that. So we do 3 minus 6 and get minus 3. Big deal, because when we square it, we get plus 9. And we add that to minus 2 minus 4, which is minus 6. But again, we're going to square it. That becomes plus 36. 9 plus 36 is root 45, which becomes the square root of 9 times 5, 9 being a perfect square. Square root of 9 times the square root of 5. The square root of 9 is 3, and the square root of 5 is as simple as it gets. So the distance between those points is 3 root 5 units. And again, it's okay to have a radical, but if you get a radical answer, it better be in simplest terms. Now, in geometry, you might have to use this idea to figure out, to answer questions like, is this a rhombus? And you may or may not recall that a rhombus is simply a quadrilateral with 4 equal sides. So a square is a rhombus, but if you take a corner of a square and you push it, and it tilts over, all right, then it's not a square anymore because it doesn't have right angles, but it does become a rhombus because all 4 sides are the same, all right? So you would use the distance formula, and if this distance from here to here is the same as this distance from here to here, which is the same distance from here to here, which is the same distance from there to there, then the answer is yes, you have a rhombus. But if any one of these distances is not the same, the answer is no. It's not a rhombus. And I will leave you to do that on your own, all right? You'll have to tell whether or not it's a rhombus just based on your own. So you might want to stop the video right now and work this out and see if all 4 of those sides are the same distance. And again, distance doesn't matter if it's radical. I mean, if it's the same radical for all 4 distances, that's as good as being the same. So, all right. Finally then, the idea of midpoint. Little extra bonus. This really isn't quadratic, but again, it's going to come in handy, all right? So the midpoint formula is simply the average of the x and the y values, all right? If you want something halfway, I mean, if you want, what number is halfway between 10 and 20? You add 10 to 20 and you divide by 2, and that gives you 15. That's the middle point, right, between 10 and 20. Simply add the 2 things together and divide by 2. You're finding the average of those 2 values. Well, it turns out for geometry and coordinate systems, the same thing applies. You take x sub 1, you add it to x sub 2, and you divide it by 2, and that gives you the midpoint for x. You take y sub 1, add it to y sub 2, then divide by 2, and that gives you the midpoint for y. Now you have an x number, comma, y number, which is a point, which that point, if you did it right, happens to be exactly in the middle of a line segment. So it looks something like this. Find the midpoint of a segment with the given endpoints, all right? So you don't have to graph this out, all right? All you need to understand is you got 1 point, 3, 5, and there's a line that extends to 7 minus 2. And you want to know what's the middle of that line. So to do that, you take advantage of the midpoint formula, which says I take the x sub 1 and add it to x sub 2. Remember, I've labeled these. And again, it doesn't matter which is 1 and which is 2. So I got 3 plus 7 divided by 2, and then I add the y's, 5 plus minus 2 divided by 2. 3 plus 7, 10 divided by 2. 5 plus minus 2, 3 over 2. So we say the midpoint is 10 divided by 2, 5, and 3 divided by 2, 1.5. And that's the answer. It's a point. It has an x value, a comma, and a y value, and they're in parentheses because that's what you're asked to find, the midpoint. So on your own, use this and find the midpoint between 7 and 10, or 7, 10, and 5 minus 4. All right? Do this on your own, and when it goes further, we'll see if you're right. All right, so did you add the 2 x's together and divide by 2? Add the 2 y's together and divide by 2? 12 divided by 2, 6 divided by 2, the midpoint is 6 comma 3. Good job. I knew you could do it. So, Your assignment then in lesson 86 is do A to E and 3 to 12, and we'll be back shortly.